and then absorbed into the what we call systemic circulation into the body is in an active form. So a drug with a high bioavailability means you could take a pill, say a 1 milligram pill, and the effect on the body overall would be 1 milligram, just as if you gave it intravenously. In other words, it's 100% bioavailable. Drugs that have a low bioavailability are drugs that when you take them orally, only a fraction of the active drug actually reaches the circulation and reaches the sites of action. In the case of the drugs we're discussing in this case, it's the central nervous system or the brain for the most part.
And so, at that particular point in time, were you aware of that, I'll refer to it as the pig study of 1992, cited in Dr. Schaefer's report?
Actually, I only became aware of it when I was provided with a copy of Dr. Schaefer's initial report. When I did my search online, I did oral administration, and the piglet study, which involved intrarectal administration, did not come up in my search, so I was unaware of it.
Now, you are aware of the fact that there actually has been a human study done involving bioavailability of propofol. Is that correct?
Yes, I am aware of the study. Actually, my colleague Dr. Schaefer and colleagues in Santiago, Chile, conducted a study in 6 volunteers very recently, and they prepared a draft manuscript which Dr. Schaefer asked me to review. And also, Dr. Schaefer himself actually drank propofol. I felt kind of bad because I said, you know, I hate to think you drank that just because I speculated on something due to a lack of evidence to the contrary.
As a result of the Chilean study, you did review it completely?
Yes.
Did you make comments on it?
I made some suggestions, and I had comments that there were problems with the study, in my opinion. It was not a controlled study. It was not a blinded study, and in fact, 1 or more of the 6 participants were actually investigators. I'm not sure how you get consent for your own study, but the principal investigator, Pablo Sepulveda, was one of the 6 volunteers for the study. So I thought that because there's no blinding, I don't know that you can put a lot of value on the assessments that were made because they were subjective assessments of drug effect.
This is not how you do your studies.
Well, most of the time when we do studies involving drugs, we like to have a placebo or active comparator, and we try to blind the observers, and so we do what's called double-blind studies with drugs in general, and or have an active comparator, which is a drug that has an effect, so that you could really be sure that you're not looking at an effect that's unbiased.
Now, when you say double-blind, are you talking about the subjects being blind to it and the observers of the subjects both being blind?
Correct.
Not knowing who's got drugs and who's got the placebo?
Well, who's got the active drug versus who's got the placebo? Correct.
So this study from Chile was not a blind study?
Not that I could determine.
And was there a determination made as to bioavailability?
5 out of the 6 subjects had no evidence of any bioavailability. But interestingly, one of the subjects, actually the principal investigator, Dr. Sepulveda, who's also a personal friend of mine, had fairly substantial levels. I think at 2 minutes he had a level which was about 2 micrograms per mil, which is actually only slightly lower than the level of propofol that was reported in Michael Jackson's femoral blood sample.
Now, did you conclude from that that maybe it's bioavailable in some people and maybe some people it's not?
Well, I agree with Dr. Schaefer. I don't think it's bioavailable from the stomach, but when you take something orally, it passes through your oral mucosa, your hypopharynx, and through your esophagus, and that mucosa can absorb drugs. And I suspect that in this case, the one volunteer, Dr. Sepulveda, that had the high levels, it was probably transmucosal absorption from the oropharynx or the esophagus.
Has there been subsequent animal studies or an animal study that indicated to you that absorption through the stomach is really not going to lead to appreciable levels in the blood system?
Well, yes. You recall when I initially wrote the letter speculating on this as a possibility, I suggested that we commission a study in animals where the drug would be placed directly into the stomach using a tube that we put down. It's very benign, doesn't hurt the animals, and administer the drug and determine if there was effect in animals, because I wouldn't have pursued a study in humans until I had first done an animal study. And we did this study. We didn't publish it because I didn't think it was necessarily appropriate for publication. It was negative. The drug that was given directly into the stomach was absorbed and metabolized, and there was no effect.
And did you want to confirm the fact that the drug couldn't be absorbed through the stomach in spite? Well, there had been an animal study, a pig study, where a rectal insertion of the drug was used. Did you think that there was a possibility of a difference between the other end of the gastrointestinal system?
Well, as Dr. Schaefer stated, when you give a drug rectally, it does partially go through the hepatocirculation, but most of it, but a lot of it can bypass the liver, so it's not the same model. I don't think it's as convincing, so that's why I felt it was appropriate to do an animal study. In the study we commissioned, none of the animals were harmed. They basically had no effect, and so it was no harm. And it answered the question clearly that if you put propofol directly in the stomach, you wouldn't expect or find a clinical effect.
Okay, and you've discussed this study with Dr. Schaefer, I presume? Oh, the Sepulveda study?
Yeah, we discussed the paper in email exchanges just a few weeks ago, but interestingly, we also had an opportunity to chat during the proceedings here when we were outside in the ante-room while the video was being reviewed. And it was an interesting chat because we talked about the volunteer with the high propofol level, and we both agreed that it could be oral transmucosal absorption, and talked about actually the possibility of developing a lollipop with propofol that could be used for sedating patients non-invasively, that is, without giving it intravenously.
So it piques your interest as a possibility of a future look at usefulness of propofol?
Correct. And I have to also acknowledge my colleague, Dr. Schaefer, because it was not just my idea, it was something we discussed together.
Now, did you published papers with the Schaefers?
I published one paper with Steve and 9 papers with his former wife, Audrey. Audrey spent 1 year with me while Steve was still in medical school. She was a year ahead of him in medical school. And then they went away and did their internship and residency at the University of Pennsylvania. And upon returning to Stanford, Audrey wanted to do a second year of research with me. So she rejoined my group. And that's why she has many more publications.
Did any of these papers have anything that would be relevant in this case?
Yes. I mean, the most important one probably is the pharmacokinetic, pharmacodynamic effects of propofol, which has been considered one of the classics in the field. In fact, I was asked to write a special article discussing propofol for the major journal Anesthesiology, and it was referred to a classic article revisited.
Now, this pharmacokinetic, pharmacodynamics, what is the difference between the two?
Well, Dr. Schaefer spent a lot of time, so I don't want to bore the jurors unnecessarily, but in a simple way, the way I think of pharmacokinetics, it's a relationship between a dose that you administer to a patient and the resultant blood level. Pharmacodynamics, on the other hand, is the relationship between that blood level and an effect on an appropriate organ. Dr. Schaefer talked about effect site concentration, which is a surrogate endpoint, or it's a way of assessing drug effect on the brain. And since we're talking about anesthetic drugs, sedative drugs, that's the critically important organ. Most practitioners, however, aren't really too interested in the blood level because you can't measure it, and certainly not the brain level. And so we look at the effect, the relationship between a dose and an effect. So it kind of goes directly to the end effect. But when we think of PK/PD, we're breaking down the dose-effect relationship in patients into two steps.
Now, when you're talking about pharmacodynamics or pharmacokinetics, correct me if I'm wrong, that's where you know the weight of a person or of a subject, you know the dose they get. It allows you to predict the blood level that you would expect.
We use models, as Dr. Schaefer's described, to get an approximation of a blood level. But as we'll show, it's not like there's a one-to-one relationship. You're often dealing with a five-fold variability. So if I give a fixed dose to a population of patients, the blood level that results will vary over a five-fold range.
What does five-fold mean?
500%.
I mean, you can get 500 times too much,
No,
or one-fifth?
Sorry, you get 5 times. So you could get, for example, if you give a dose of propofol, you could get a blood level that could range from 1 microgram per mil to 5 micrograms per mil. That's just variability among patient populations. Similarly, there's a variation between the blood level and an effect within a patient population. Of course, we can determine means, and that's what we use in a lot of the modelings processes, but when you're dealing with individual patients, as we'll discuss later, I hope, I can demonstrate the challenge in looking at pharmacokinetics and dynamics.
So pharmacokinetics, you give a dose, you can get different blood levels, and then pharmacodynamics, you can get a certain blood level, but you get different effects on the patient.
At the same blood level, yes. In different patients, not necessarily the same patient. I'm talking about a population of patients.
This paper that you did with Dr. Schaefer involving PK/PD, pharmacokinetics and pharmacodynamics, was that published?
Yes, it was published in Anesthesiology.
And does that illustrate the variability that you can get with doses and
Yes, I don't have a copy of the paper, but I guess you do.
I've got a copy of the paper.
Good.
Yeah.
Just, again, I don't want to bore you all with unnecessary detail, but this is the administration of propofol during surgery in this particular patient. These are the actual blood samples that we drew and measured of propofol. And you can see that during the operation here, the solid line is Dr. Schaefer's modeling of the pharmacokinetics of the drug. And during surgery, you can see the model significantly under-predicted the actual blood levels. These are the actual blood levels. These were the levels that were predicted by the model. So I think it's just a good illustration of some of the variability that we're dealing with. And if you go to the next page of this article, I'll show you an example of what we call pharmacodynamic variability. This there's another example of kinetic variability to the side, if you want to show that one. Again, where samples...
Is the other one?
Yeah, you can see here, this is the model concentration, and here's one sample was below the curve, and then shortly thereafter another sample was far above the curve.
Okay, could you explain that? What do we have on each of the axes?
Oh, I'm sorry. This is the propofol concentration, and this is the time. And this is the infusion rate here of propofol that was given for providing anesthesia.
You got all those dots. Do those represent